So this is a ATC cabinet kind of troubleshooting and how-to class. I wrote this for an agency, well, south of here because we're in Maine, but essentially this gets down to the nitty-gritty. Shouldn't take too long. I have kind of three sections here. Given that these are 45-minute sessions, I've trimmed this presentation from its original intended. I've trimmed a lot of slides out of it. So first I want to talk about the ATC cabinet progress. It's been 11 years since our first deployment, and I want to kind of review where we are with ATC cabinets, how far we've come, why we care, and talk briefly about what we have in mind for next. Then after that, troubleshooting. This is a technician's class here, the technician's session, not really a class. And then I'm going to end on ATC cabinet how-to. Now, there's only one how-to here because my biggest takeaway for everybody is to know how to download or how to view and download the monitor logs remotely. Because when you're in the field and you're stuck, you need to ask for help. We, the technical resource, need all of the data that we possibly can get. So, all right, let's rock and roll here. So first, let's talk about how far we've come. So we've been doing this for over 10 years. This is the first ATC cabinet ever deployed, Cedar Park, Texas. It's essentially the same stock cabinet, except for these two switch packs right here. They were added for flashing yellow arrow. So it's been running really well for 11 years. And I'll say that and probably jinx myself, but we have over 8,000 ATC cabinets deployed across North America. And that number is not only just Swarco McCain's number from our own internal tracking, that's our estimation based on observations in the industry. Swarco McCain is actually building more ATC cabinets than any other type right now, which is saying a lot for a Southern California company. We're also continuously making improvements. We're building 6th and 7th generation assemblies, improved from user feedback and our own observations. So we know what's working. We know what needs to be improved. We take into account everybody's feedback and ideas, and we're upgrading our assemblies. And then the third thing that we've been up to, ongoing training and education. This is a priority. This is my priority because we're committed to the ATC cabinet. We were pioneers with EDI and its development. I cannot ask anyone to adopt the ATC cabinet and its concepts of safety, efficiency, cost. I cannot say, hey, Maine, state of Maine, please, this is the cabinet for you, without teaching everyone how the cabinet operates and, more importantly, how to keep the cabinet operating. Fixing the cabinets. These are electronics, and as nothing's perfect. Things will go. We will have fault events, flash events. We need to keep everybody trained and up to date on how to maintain this equipment. So, thinking about how far we've come. So, for example, Swarco McCain, we now offer fused field output termination assemblies. So, a 1 amp fast blow fuse saves the cabinet from losing its high density switch packs. These are hundreds of dollars. So a fast blow fuse, $3 versus $300 or $400. I don't know what these cost anymore. So it's another troubleshooting point, but it's an easy point. Now the idea here is that if the cabinet, something gets hit in the intersection, short circuit in the field, the short circuit runs into the cabinet. What happens today is it damages the switch pack. The cabinet then goes to flash, and then the flasher takes over, and then that short circuit now influences the flasher and damages the flasher system. So instead of that, we'll blow a fuse. Yeah, we'll have a dark signal, or I'll have a dark indicator. However, we won't have a damaged cabinet. We won't have a $400 switch pack damaged, or however much these cost. Stay there. Auxiliary I/O assembly. This is cool. This is several states specify that the cabinet must include this assembly. This is 21 additional inputs and 8 outputs. The outputs are rated for 10 amp, 110 volt AC. So I can using controller logic or just controller operation, I can actually turn on indications in the field, preemption confirmation strobes, blankout signs that require more power than the switch packs can provide. Other things I can activate from the controller, and that aux-IO assembly is essentially another SIU, handling inputs and outputs. Low voltage improvements, backup power and such like that, improving on the original design of the low voltage cabinets, and of course upgraded pluggables. We've worked with EDI, giving them feedback, we've made significant improvements to the switch packs and the monitors and such. So improvements, any of these improvements that we make to our own assemblies and such are retrofit friendly for Swarco McCain cabinets. Now there's, in a perfect world, all the different cabinets and all the assemblies would have interchangeable assemblies, but the standard wasn't written that way. The standard was written to be functional. So as a retrofit example, South Portland, Maine. So this cabinet was put in July of 2022. And a couple of weeks after it was installed, there was a wreck at the intersection, and the vehicle collided with the riser and damaged the signal, the signal cable. Short circuit fed back into the cabinet and damaged the internal assemblies inside the cabinet. The cabinet developed gremlins, and then random channel faults, multiple indications, conflicts, all that kind of stuff. And then the cabinet service record became spotty. In December 2024, we implemented the final repairs and actual rework and efficiency improvement in the cabinet, replacing the service assembly, replacing the output assembly, and replacing the field output termination assemblies with the new fused photos. So something that we couldn't do in a NEMA cabinet, we did in the ATC. We changed the internals. We did an exact one-for-one swap out. I'm standing in front of my picture. We did an exact swap out, replacing these assemblies with new and improved units. And now the cabinet is more bulletproof because we're on we're using the fused output termination assemblies. So if that happens again, the vehicle hits that riser and crushes that riser, then we'll blow fuses, not blow the cabinet. We did this without having to use the 4 little bolts method of repair. 4 little bolts. You loosen the bolts from the cabinet foundation. You push the cabinet over. You put a new one up. So this is an example of the modularity of the ATC cabinet, especially in repairs. We can repair these cabinets now without having to lift them off the pad. Took us about 45 minutes to change these assemblies. Now, the contractor also did replace the crushed riser piping and everything like that, so it took a little bit longer because they had to dig all that out. So it was a nice, cold December day, but since then the cabinet has been, we fixed the problem. All right, let's talk about cabinet troubleshooting. So I've kind of been doing this my entire career, but key concepts of cabinet troubleshooting. Number 1, start at the beginning. Start from the top to get to the problem. And what I mean by that, and I'm going to use, throughout this part, I'm going to use my little mule cabinet here. This is the cabinet I have at my house. It's kind of a specialty cabinet because it's DC assembly, and then there's an AC assemblies as well. I opted to configure this for DC for this session because I've got my pretty little light box here. But starting at the top of the cabinet, or starting at the top of the problem, means start with the ADU. Every technician needs to look at this. They don't need to worry about the controller. They don't need to worry about anything else in the cabinet. When they first open that door, they need to take a look at the ADU, because every single ATC cabinet has this exact same ADU, and the Maine DOT spec says it should be in the top of the cabinet. Also look around. Maybe these are, it kind of sounds like common sense. You know, you pull up to the intersection, it's in flash, look around. Is everything standing? Did a snowplow knock down a ped pole? Anything like that? We had a session earlier today where they were talking about the ped base, the access panel had popped off, and it was full of snow and mud, and that's why the signal kept going into flash. So take a look around, make sure that all the structures are standing and nothing's damaged. And then get the logs, because remote support is critical when the field technician needs help. They need to phone a friend. We need the logs. We need to know what's going on. We need as much information as possible. So if there's any other, if there's no other takeaway from this session, other than or from what I've talked about, I want everybody to know how to get the logs, how to be comfortable with getting the logs out of the EDI monitor. Because also, every ATC cabinet has this exact monitor, the 2212, high voltage or low voltage, but they all work the same. This is an improvement. Well, yeah, it's an improvement over NEMA and Caltrans cabinets, because over the past 40 years, there have been different monitors, different manufacturers, different models of monitors with different feature sets. But we come out of the starting gates in ATC with an Ethernet interface. So getting the logs is much more uniform. This makes much more sense. All right, so I'm going to skip this slide. I put this in here as reference because what I wanted to do is, so I'm not going to skip this slide. And what I wanted to do is talk about how the ATC 5301 cabinet is, the specification is a functional specification. The Swarco McCain cabinet, or the McCain cabinet, everything here is yellow, of course, but this cabinet, in theory, operates the exact same as all of the different makes of ATC cabinets here in the state of Maine. This is all we had to go by as manufacturers. This is how we're supposed to build our cabinet. Now, the side effect of that is we use different assemblies, different connectors. The assemblies are not interchangeable necessarily from a McCain cabinet over to an Econolite SafeTran or a Mobitrex or a Trafficware, and vice versa. So there has to be an understanding that we just can't pull an output assembly off the shelf that was made by McCain and go stick it in a SafeTran. So it's unfortunate, but that's just the way it is. So this is what I call the trade show layout, 352i cabinet layout. This is very old, actually. So this is a great way to identify the different components or the different assemblies in the ATC cabinet. Again, starting from the top, the ADU, the controller, input assembly, output assembly, and then on the back side, power supply, DC power bus, field input, field output, termination assemblies, of course, where we land our field wiring. A little bit closer to home, though, and at the bottom is the service assembly. Closer to home, though, here's the main spec. I hope you guys haven't changed this yet. If so, I need to update my drawing. At the top of the cabinet, the auxiliary display unit, test panel for detector test switches, the space for the controller, could be a McCain, Econolite, Trafficware, Unix. Then our input assemblies and output assemblies. 32 channel is the spec. You don't have a 16 channel spec at all.
I don't believe so.
Yeah, I don't think so. Service assembly, and then over here on the right side bay, because these are all 350i cabinets, this is the card storage rack, or the slide lateral rack, or the Steve Landry rack, depending on what name you want to give it. This is where we put in the spare parts, so monitor, switch pack, detector cards, SIUs, and the value here is with 850 intersections across the state of Maine. We don't want to have somebody drive all the way to Fort Kent from Portland, because they were their own call service at the time, and then they get there and realize they didn't have a monitor on the truck. No, we'll have one in the cabinet. But I do want everybody, if you're going to use something like this, I do want everybody to be sure to not put bad parts inside the cabinet or on the slide lateral rack, because I've seen several switch packs inside of these cabinets that says maybe bad. Okay, that's not going to help the next person. You always got to solve for the next person here. All right, so cabinet troubleshooting. You always start with the ADU. Take it from the top, right? So the auxiliary display unit shows the live intersection status, and if there's a fault. the blue indicators point out the channels that are contributing to the fault. The LCD will tell you the fault message, and it will actually freeze the clock and tell you when the fault occurred. So technician pulls up to a cabinet that's in flash, they open the door, blue lights, blue is bad, and then it tells you what's wrong. In addition, so say somebody goes and fixes the cabinet, police officer opens the door and resets the cabinet, and then they call out and say, hey, by the way, the intersection went in flash over the weekend, but it came out of flash, but we want you to go look at it. So when the technician comes to visit the cabinet, which is now running perfectly, they can go and, using the front panel of the ADU, oops, wrong button, view the previous fail log, and then the ADU will actually replay this or display the state that the signal was in at that time. And using the menus, you can navigate through and see your channel and channel voltage and current consumption for each color, each output at a time. So it's very, very helpful in case somebody healed the cabinet, but then someone has to go in, has to come afterwards and investigate why it went into flash. So very powerful tool, and also you can do no harm. Let me get this. You can do no harm by touching the buttons on the ADU. I encourage all of the technicians to familiarize themselves with the ADU because you can't break it. Now, you can deprogram the controller, you can do weird stuff, but you cannot hurt the cabinet by pushing any buttons on the ADU. On a NEMA monitor, you can reprogram the monitor, you can factory default it, you can do this and that. But on an ATC cabinet, the only way to configure the monitor is by reprogramming this key with the monitor key configuration tool. Even this key slot on the monitor, this is read-only. There's no way to change the monitor configuration without a key programmer. So any technician that says, I don't want to push any buttons because I don't want to screw anything up, they don't have to worry. So everybody needs to familiarize themselves with the ADU. In addition to just viewing old logs and everything, there's an even cooler feature on the ADU called the Diagnostic Wizard. This little blue guy up here, we call him Scott. So when the cabinet is in flash, let's kick up a little fault here. Serial bus 3 fail. If someone says, I don't know what serial bus 3 fail is, and like I need a manual, I need training and everything like that, the answer is, hey, just push the help button. The help button will give the definition of the fault, and then by pushing the next button, they will actually be told what to check. So in this case, the serial bus 3 fault, it says, serial bus 3 communication to these, got a little arrow, and saying it has failed. The third fault in 24 hours is latched. Little blue lights, blue is bad. I push next, and it says, check the high-density switchbacks or high-density switchback channel enable program in the CMU data key. All right, that's pretty easy. I'll pop the switchback back in because it just, it came out for some reason. Oh, cabinet's fixed. Thank you, Scott. You helped me fix the cabinet. So an example of the diagnostic wizard, lack of signal. So at 6:36 and 59 seconds on October 12th, 2021, we had a lack of signal fault. So you push the help button. Screen 1, no signal color is active for these fault channel, again pointing to the little blue lights. Forgot to reset my monitor. Screen 2, output voltage is active, but no load current is active on these outputs. What's actually cool about this is as you're pushing the next button, the lights or the indicators on the ADU itself are more and more indicators are turning off, and as it's narrowing in on the problem. So the first screen, all of the signal status lights are all on, or then you push help, and then the signal status indicators for all of the channels that aren't involved in the fault turn off, and then you push next again, where it says output voltage is active but no load current is active. Only the color that it's mad about is active. So the technician is able to zoom in exactly on the channel and channel color that is contributing to the fault. So that works for lack of signal, for conflict, for multiple indication, all of these things. So the technician is being guided to the solution. And then the final screen, it says there's an open load. Check your field wiring, return is connected and tight, signal heads are good, flash transfer relays. So that's all the things that it wants you to check right there. This is the monitor telling you how to fix the cabinet. All right, so this presentation was originally written for an agency, and they asked me to come up with some troubleshooting scenarios. So I have 6 scenarios that the most common that I could think of, and I'm going to kind of run through these real quick in the next 10 minutes that we have left, 10, 15 minutes, whatever we have. Scenario number 1 is serial bus 1 error. Now, serial bus 1 in an ATC cabinet is used by the controller to communicate with the cabinet serial interface units, or SIUs, and also the CMU. So if there's a serial bus 1 error, then the monitor is mad that the controller the monitor is mad that the controller isn't communicating properly. This could be a bad cabinet ground, this could be a faulty wire or faulty serial cable, this could be an issue with the controller or issue with the cabinet serial bus. But it's unclear to the user. The user walks up and it says, serial bus 1 fault, what's that mean? I don't know. The help screen says check the controller. So troubleshooting ATC cabinets from the perspective of the controller. So far I've just said, hey, only look at the ADU. But in some cases, using the controller is very helpful because we have screens in all of our controllers. And I apologize, I do not know the screens for trafficware. I keep meaning to go downstairs and find out, but we'll get there. But in every single one of our controller manufacturers' softwares, we have a screen that tells us how well the controller is communicating with the cabinet. So like in Omni, for example, it tells me that the frames transmitted from the controller, the frames received back from the cabinet devices, each individual device, or SIU or CMU, and then if there's any frame errors. If I see those frame errors ticking, I've got some garbage on the serial bus, or I've got to have a failed device, or a bad ground or something. So in McCain, in McCain Omni, it's 0733. In EOS, it's 772. In MaxTime, it's 177. D4, D07, CPAC, 25D. So any technician can quickly go and look at this. Like earlier, the town of Scarborough, I was talking to them, and they run CPAC. So I'm like, okay, you guys can go to this screen and see if you have any cabinet comm issues. So this is extremely useful because it takes all the guesswork away. Now, if you can't read anything from that, embedded in this presentation, again, this is the value of the take-home part of this, I have these troubleshooting flowcharts. So again, start from the top, and you're going to see this common denominator. The ADU says serial bus 1 fault, and then you work down through this flowchart. Hey, is the controller unit turned on? Is it and programmed correctly? The SIUs, did the SIUs pop out? The various things here of what could go wrong from the cabinet perspective. Scenario 2, CU latch fault. Now, it's very important to note, the monitor, the cabinet monitor unit is always going to refer to the controller as the controller unit or CU. Doesn't care if it's a McCain or an Econolite or whatever. That could give, it doesn't care. So if the controller unit decides to put the cabinet in flash or latch a fault, it means the controller's not happy. The help screen actually says check the controller. So did anything change in the controller programming? Like a lot of times, contractor goes out to install a flashing yellow arrow and whatever, and the first thing they do is program the overlap in the controller, changing the channel permissive, and then without updating the data key, they create a disagreement between the controller and the monitor, and then once the controller realizes that the monitor is not programmed right, it'll latch a fault. Lack of signal fault. This is a popular one. There's several different lack of signal indication or reasons for lack of signal inside of an ATC cabinet. So I actually use the next 2 scenarios for this. Lack of signal is kind of like red fail, but it's also has to do with load current consumption and the program load current thresholds in the monitor key. Typically, we leave those at 30 milliamp because we don't want to do maintenance mode load current monitoring from the perspective of the monitor. We want the controller to do that. We don't want to go in flash because a lamp goes out. We want to get a message, a notification message that the lamp's out. So, what does the ADU say? This is where the help wizard is very useful, because the help screen will actually go through and tell you if it's a lack of signal due to no voltage, or lack of signal due to no current consumption. So it really kind of dials in on what the problem is. So again, start from the top. ADU signal. Verify that things are plugged in. Flash program blocks, flash transfer relays, field signal wires, switch packs are good, so on and so forth. And then at the very end, if you verify everything in the cabinet, then you can go out in the field and start the fun journey of tracing down bad field wiring, like a snowplow knocking a cover off of a PED base and it filling up with snow and ice and water. Oops. Lack of signal fault again. I'm going to blow through this because the emphasis there is that lack of signal could mean multiple things. So don't just get stuck on Don't just get stuck on, oh, I know what lack of signal means. That means it's a bad switch pack, No, it could be multiple things. So next scenario, serial bus 3 fault. It's important to note what serial bus 3 is first. Serial bus 3 is used by the monitor to communicate with the switch packs, with the ADU, and with the high density switch pack serving as a flasher. You see these pretty little flashy blinky lights here. That's the monitor constantly polling the switch pack, saying, what are you doing? Are you alive? What's your voltage and current consumption for each of you, or for your active output? Tell me how you're doing. Unlike a NEMA cabinet where you can pull a load switch and then just put in a red jumper or a jumper in that load bay, if the monitor loses a switch pack that it's expecting that it needs to have, that's programmed to talk to, it's going to get mad. It's going to go to fault until someone brings it back. A little hard on my equipment. So, again, if technicians forget what serial bus 3 is, that's why we have a help button. It's nice to have the technology help the user. And then last scenario, scenario 6, flasher alarm active. Okay, so there's no help screen for this, but on the ADU, if there's something wrong with the flasher system, the bottom line will show a flasher alarm active. And more importantly, and this is cool for the state of Maine, EDI EC Comm will show a flasher alarm active that Maine can access through MainLink. Is it MainLink? Okay, I've been getting that wrong all week long. But now I got it right. Through the AI glance system. So we can now pull up the monitor status using the Ethernet interface and kind of get a look at it. We as controller manufacturers are this close to sending the flasher alarm status object as an alarm object through the controller. Again, being pulled by central monitoring systems like Glance. MainLink. Close enough. Now, so the flasher alarm's not going to put the intersection in flash, but let's say a storm's coming, and that flasher's been burned out for months, or the flasher's wonky, which I don't think they can get really wonky. Yeah, let's say one of the fuses fails or something like that in the flasher. So then when the cabinet does go to flash, we go dark. Flash is safe. Flash is all right. I mean, flash isn't the best, but flash is accepted by the MUTCD. Dark, however, is not, and dark's the scariest. All right, good. You're happy. So, troubleshooting the flasher, pretty easy. Now, one thing to note also on the flasher, you have blue indicators showing the wig and wag. Each flasher, high-density switch pack flasher, should have 2 wigs, 2 wags. If you ever find yourself in a scenario where you don't have 2 wigs and 2 wags on each flasher unit, that means that you have a problem with your flasher. Those blue indicators are not passive indicators saying, oh, I'm powered and I'm in flash mode. No, those blue indicators are saying the flasher's powered, the flasher fuses are intact and wired in, the harness connecting the service assembly to the field output termination assembly is intact, the flash transfer relays are seated and operating correctly, and then that flash sense signal returns from the flash transfer relays back to the flasher unit. So those blue lights are not passive. That is feedback from the flash transfer relay itself saying, or from the flash transfer relays from the field output termination assembly saying, yep, this thing's ready to rock and roll. If the cabinet goes into flash, we're going to have consistent flash. That is a massive, massive improvement over Caltrans and NEMA because we didn't have that kind of feedback before. Last one, 24-volt DC failure. This is a really fun one. But again, takeaway number 2 here, always start with the ADU. Takeaway 1 is send me the logs. Takeaway 2 is start with the ADU. Go to the ADU and work your way down from there. The help screen in the ADU is very useful, but also if you start from the top of the cabinet, you can start tracing down the 24-volt DC power throughout the cabinet assemblies. This flowchart is very, very valuable. Now, I don't have one for 48-volt DC fail. I don't have a flowchart for that because the ADU itself is powered by 48-volt DC. So if we lose 48-volt DC, then the ADU is dead. Kind of pointless, and the help button doesn't do anything. Okay, so cabinet door switches. I'm just going to pause on this for a moment. These are not door switches, cabinet switches. The cabinet switches defined by the standard, this is what they do. Now, Maine DOT has a controller power switch that turns off the controller. Kind of useful. I actually asked, why do we need that in the modern cabinet? And then somebody, I think it was Joe Herr, who said, not all controllers have their own power switch. Whereas, Econolite, McCain, we have a power switch on our controllers, but not all of the controllers that can run this cabinet have a power switch. So that's kind of convenient. I like that feature. Circuit breaker guide. I need to actually update this for our new assemblies. But the circuit breakers, where they're located, what they do. We're actually doing away with the 4 circuit breakers or 8 circuit breakers on the output assembly because they're 5-amp breakers and they never trip. So the standard calls for 1 circuit breaker per 8 switch packs. So that's what we're going to because they never tripped. Result of removing components. This is what we can pull out of the ATC cabinet with it staying in flash, or what will make it go to flash. Now, cool feature in the EDI CMU is I can pull the data key out and reprogram it. So let's say somebody forgot to program the IP address. They drive back out there and they put the IP address for the monitor in the data key, as long as they keep the door open. Now, in my little mule cabinet here, I don't have a police door, so and I don't have door switches. So the door switch is wired. The cabinet always thinks its door switch is closed. So the minute I take this data key out, I put the cabinet in flash. I've had one agency. I'm not going to mention who. I've had one agency who actually has taken a data key out of an ATC cabinet and taken it back to the office. And what they did was they just unscrewed the door switch, so the cabinet always thought the door was open. And I yelled at the guy who told me he did that because the problem is that that agency has rather dirty power. It's a large city in the Mid-Atlantic. They have very dirty power. And if that cabinet reboots, if that monitor boots up without a data key, it has 0 configuration. So then someone's going to get a call, hey, lights in flash. They're going to drive out there, and they won't be able to fix the problem because that agency doesn't give key programmers to the field techs, and the data key was removed. Well, we typically recommend, this is a little chintzy, but zip tie the data key to the monitor handle, because then, you'd have to be a villain to take that out. A whole nother class on monitor keys. All right, now replacing assemblies. I'm going to go through this rather quickly because part of this is for take home. So when I got this cabinet in July, shipped to my house in Thomaston, I was then able to do something I've wanted to do for a very long time, and that's write a procedure on how to replace all of the assemblies. Now, granted, it's going to be a little different for Econolite trafficware cabinets and such, but for us, replacing the assemblies, or for us ATC cabinet users, excuse me, replacing the assemblies is pretty much uniform. So this section kind of covers how do you replace the assemblies, what tools do you need, or is the cabinet going to be in flash? So I'm going to kind of just move through this quickly. So replacing the ADU. Let's start from the top, right? Let's talk about changing the ADU. Tools required: Phillips head screwdriver, precision flathead screwdriver. I'll give you a clue. That's all of them are going to need those two tools. It should not put the cabinet in flash. Unscrew the ADU, disconnect the serial and power cables, installation reverse of removal. Cabinet power supply replacement. You'll already be in flash if your cabinet power supply is faulted because you lost your DC source. So Phillips head screwdriver, precision screwdriver. Again, unscrew, disconnect, replace. I think I was a little thorough here. Power down the clean power bus circuit on the output assembly. You can do that if you want, but it's a power cord. It's an AC power cord. I just wanted to kind of conform. ATC cabinet serial bus, DC power, and clean power bus replacement. Phillips head screwdriver, precision flathead screwdrivers. Rinse and repeat here. So turn off the clean power bus, unplug it, pull it, replace it. Input assembly replacement. So this should not put the cabinet in flash. However, you're going to want to set recalls because you're about to take away all your detection. So Phillips head screwdriver, precision flathead screwdriver, and a 5/16 or crescent wrench for the McCain cabinets because I have a little ground lug right over here. Unscrew it, disconnect the wires, change it. Field input termination assembly replacement. Screwdrivers, again, set recalls because you're going to lose detection. Label everything, label where your field wire is terminated. Make note of where these harnesses, where they're plugged in. It should, there's a label on the harness that couples the input termination assembly to the input assembly, but there's also a silkscreen notation saying, hey, plug J1 into J1. So disconnect and then replace.
Is that on the rack or is that?
That's on the rack. It's on the back side of the cabinet. Yeah. Yep. Output assembly replacement, part one. This was too much to put on one slide. So Phillips head, precision flathead, 5/16 wrench. You might need some wire cutters to cut some zip ties. So tear down, label, or tear down everything, and then next, disconnect harnesses, and then installation reverse of removal. Now, most importantly, make sure your CMU harnesses, make sure all of this is seated well, because if you, like in this connector right here, if that's partially popped out, you'll stay in local flash. But also, these harnesses, coupling the output termination assembly to the output assembly, make sure you plug them back in their proper ports. Like R1 goes to R1. If you get this wrong, then that means that your switch packs are going to be driving output terminals that are different than what that switch pack is supposed to be driving. If you plug R1 into R7, then switch pack 1 is driving switch pack 7. Dangerous. No, actually deadly. Because the cabinet won't know. So, I mean, yeah. Let's see. Oops, too far. Field output termination assembly, kind of the same idea as replacing the inputs. Label everything, fold it down, unplug your connections. Again, everything is labeled, so make sure you plug your harnesses back into the proper ports, and then put it back together. Service assembly. Now this is going to make you go completely dark because you're killing AC power. Disconnect your utility mains. So go to the service disconnect and kill power there. And then just using these tools here, let it rip, tear it down, and replace it. The value here isn't like a live training right now. The value is if the technician takes note of this, makes their own handwritten notes, and then they can quickly repair a cabinet in the field in the middle of Holton or Thomaston or wherever, All right, so last thing, sending in the logs. This is my priority this week is I want everybody to know how to do this. I love ATC cabinets. I love talking about their features and benefits. But at this point, we have a lot of them out there, and everybody knows everybody needs to know how to do this. So, looking at this from the EC Comm perspective, the EDI software. There are some ATC cabinets from earlier deployments here in Maine where the monitors weren't programmed. They don't have an IP address. Guess what? The default IP address is 192.168.1.100. So the technician can plug into the monitor directly, set their laptop interface to be compatible with that. So maybe 1.101, and then we can then activate or then use EC Comm to get the logs. So let me switch over real quick to EC Comm. Close all this crap. So EC Comm has two features that I really care about. It's great software. It looks, it's been around for ages. Very functional. It's not super pretty, but it's super functional. So the first one is status. So I can open up and view the monitor status, view the cabinet status. I push the update on button, and it gives me the status in real time. Now I can see this through MainLink. I can see this through your, well, I can't, but you guys, Maine DOT can access all of these cabinets remotely. You have the capability to access these cabinets remotely, look at status. So when they get a call saying, hey, the intersection of First and Main and Rockland is in flash, the first thing they can do before they dispatch is go in and pull up the status, because it updates the status in real time. And it also tells you if there's a fault, and it'll tell you what the fault is. Switch pack 4 serial bus 3 error because I just unplugged it. And then channel 7 and 8 are shown with the red indicator. So when they dispatch, they can say, all right, on-call person, go out and fix it. By the way, you're going to need a switch pack because it's mad. So that updates in real time. That's very useful. Of course, this is a DC monitor, so I'm looking at DC signals, like 48-volt DC is the cabinet, or is the monitor input power and such. Now the other extremely valuable thing is log. I did that too fast. So you push the Get Logs button and then say All Logs, and it does this Windows 3.1 cascade thing. And it shows me all of the monitor logs. Once it pulls these logs, it pulls them up as text files. I can go and say, File, Save. So each one, I just go and save it, zip them up, send them to your technical support resource, me or whomever else. So like the chronological event logs, the last 300 events in chronological order, where the newest event is log number 1. So non-latch flash reset event. That's because I just unplugged and plugged that switch pack back in. Previous fail log just filters the previous fail events. AC line event log. I'm fascinated by this one. It shows me my AC line events. I haven't power cycled this since Monday. But also, most importantly, this indication right here, N reset not active. N reset is the monitor and controller talking, excuse me, my eye was itching. So N reset is a signal sent by the controller to the monitor saying, hey, I just reset I just reset. So the monitor actually knows whether the controller's alive via another signal not carried over serial bus number 1. So N reset not active, but a power event might indicate that the monitor itself powered down, but the controller stayed up. Monitor reset event logs when someone pushes the button or when the monitor itself resets itself. So if someone says, oh, the cabinet kept going into flash, and then, but nobody did anything, and then you open this log up, and then you can say, oh, look, somebody kept pushing the button. So that's weird, because you guys are telling me that nobody reset the cabinet, or the other way around. You actually know when someone pushes the button versus when the monitor decides to heal itself. And then configuration log, useful for just seeing how the data key is programmed. And then my favorite, the fault signal sequence log, shows me the last 30 seconds of what that monitor saw in that cabinet prior to the fault. Now, in the old NEMA monitors, it would give you 5 of these, and the ATC monitor only gives you one. It gives you the last fault. So this is a playback of where we were. So like channels 9 and 11, for example, this is a flashing yellow arrow operation. So those overlaps are flashing. That's what this gap means, and so on and so forth. So very cool. So save all those, zip them up, send them to me. And that's lunch. Not really. It's 3 o'clock here.
Question, you're getting all these different logs. Now you showed off how for a technician it's so valuable to look at the AU. Would it be valuable if we displayed information in that same format, or is there a way of displaying it in that same format?
Displaying the ADU status.
Remotely. Download logs, whatever it is, so it looks like as if you, like a remote front panel for an ADU.
Yeah. I don't have an Ethernet connection to the ADU, so my Ethernet connection is to the monitor.
Yeah.
So I would need, EDI would have to create an interface or release their API so someone could build a remote ADU
I'm
using.
just wondering whether or not it's like valuable. Like I'm thinking,
I know.
a technician goes in and he now knows how to do that. Let's say he opens up Maine Link, and instead of him opening up a remote front panel, he opens up the ADU and he goes, "Oh man, I better bring this with me."
Yeah, if they could turn EC Comm into a browser-based interface, which would be the remote ADU that you're talking about, the entire industry would thank EDI.
Well, I'm kind of thinking, do we try grab that data from them and simulate? In other words, I don't know how valuable. I don't repair the traffic cabinets. I actually don't know how valuable, but it sounds like from what I heard from you today, that the ADU is what everybody uses as a technician. So having something that would re-display in that format, because normal technicians don't know how to read what you're just showing them right now.
Yeah.
It's just so difficult. Whereas the ADU looks like it's really nice and it looks good. So the question is, should we be doing that?
Yeah.
We created a remote front panel for Siemens.
Are
web browser.
when you say we, are you saying AI?
AI.
Okay.
Yeah,
All right.
so
All
like
right.
their
I
remote
thought
front panel,
we
they
was
don't actually
ambiguous.
have one. We did a telnet session and got all the raw data and displayed it basically for them. So that's kind of, I'm just thinking like, do we take the data from the conflict monitor and put it into a format like the ADU?
So the only yes, I would support putting the ADU up in a remote access interface of through Glance or EDI coming out with an API to where you could browse to the monitor and have a virtual ADU like we have virtual front panel or remote front panel in our controllers. The only hang up there, this is a technical obstacle for EDI to solve, is I only support one connection to this monitor at a time. So for example, there's one controller manufacturer whose software, I won't say their name, but it's Max Time, software can connect to the CMU. And then I don't know how they did it, but you can access the live CMU info, you can pull the logs, and I think MyoVision did the same thing. However, once that connection is established between the traffic controller and the monitor, and that connection stays active, so it's going to be active all the time, then no one else can access the monitor. So it effectively locks out the EC Comm software. So that you would have that same risk with Glance, or if McCain, if I put a monitor widget inside of my Omni web server, I'd have that same risk. I'd be locking out another application.
Does it not allow multiple IP addresses?
It doesn't. Only one connection at a time. It's kind of annoying, but it's been that way for a long time. So, I mean, I would 100% support EDI giving us a web server that gave us all of the functionality of EC Comm combined with the functionality of the ADU and the help button. And then we wouldn't care about ever using EC Comm ever again. But Rome wasn't built in a day.
Yeah.
Cool. Questions? Good. I gotta pee.
How many How long do the logs last?
The logs last the 300 rolling logs. Yeah, it could be it could be years. Yeah. The logs are burned to flash. So the only time the logs are lost is if a technician changes the monitor itself or somebody clears the logs, and you can clear them through EC Comm or the front panel of the ADU.
And that's what you were showing before.
Yeah. So, all right. Thanks, guys. Cheers.